Welcome to the DIY Honda Garage channel. The DTC P0714 error code indicates an intermittent failure with the automatic transmission fluid ATF temperature sensor in the Honda Odyssey models from 2011 to 2017. This code is critical as it relates to the performance and efficiency of the automatic transmission. The ATF temperature sensor is essential for monitoring the temperature of the transmission fluid, providing data to the engine control unit, ECU, for optimal transmission operation. The sensor typically resides within the transmission assembly. It is crucial to troubleshoot this sensor due to its role in preventing overheating and ensuring smooth gear shifts. If the temperature of the ATF is inaccurately reported, it can lead to suboptimal performance or potential engine damage. This code is specifically an electrical circuit problem and is not related to any mechanical issues within the transmission itself. An important note is that using an engine block heater might lead to incorrect temperature readings, thus exacerbating the problem. The DTC P0714 error specifies a failure related to the automatic transmission fluid ATF temperature sensor. This sensor has the primary responsibility of monitoring the transmission fluid's temperature, which is critical for smooth operation. The sensor is positioned within the transmission assembly, ensuring it can accurately gauge the temperature of the fluid circulating through the transmission. The data gathered from this sensor is vital for the engine control unit, ECU, to make necessary adjustments for optimal performance, particularly during heavy loads. An accurate temperature reading is essential to prevent overheating, which could lead to serious mechanical failures. Since the issue is categorized as an electrical circuit problem, it's more about connectivity or sensor failure, rather than any physical obstruction in the transmission. Several possible causes can lead to the DTC P0714 code being triggered. The primary cause is an electrical circuit issue. This could involve damaged wiring, loose connections, or corrosion that interferes with the signals being sent to and from the ATF temperature sensor. Another likely cause is a faulty ATF temperature sensor itself. It may not be accurately reading the fluid temperature due to internal failure or degradation over time. Improper connections in the electrical system can also lead to intermittent failures, causing the sensor to send incorrect readings to the ECU. It is essential to check all these elements methodically to identify the root cause of the DTC. Moreover, it's important to ensure that external factors, such as not using an engine block heater, are being adhered to, avoid fleeting or erroneous errors. The symptoms associated with the DTC P0714 error code can significantly affect vehicle performance. For instance, one of the primary symptoms is transmission overheating. An incorrectly functioning ATF temperature sensor might lead to the ECU believing the transmission fluid is cooler than it actually is, resulting in increased strain on the transmission. Erratic shifting can also occur. The transmission may shift too early or too late, which disrupts driving smoothness and can lead to potential damage. Additionally, increased fuel consumption could be recorded as the engine works harder to compensate for poor transmission performance. Drivers might notice poor acceleration or difficulty in gear engagement, all of which may indicate a failing ATF temperature sensor. Identifying these symptoms early can potentially save from further damage and higher repair costs. The first step in troubleshooting the DTC P0714 error code involves turning the ignition switch to the on position, specifically to position 2. Once the ignition is activated, the Honda Diagnostic System, HDS, should be used to evaluate essential parameters. This includes checking the automatic transmission fluid ATF temperature from the AT data list and verifying the engine coolant temperature ECT sensor 2 from the PGM FI data list. These readings should ideally be consistent with ambient air temperature. If both the ATF temperature and ECT sensor 2 are aligned with the ambient temperature, it typically indicates that the system is operating normally, allowing the technician to proceed to further diagnostics. This initial step is crucial for establishing a solid baseline from which to diagnose the intermittent failure. Following the initial checks, the second step requires the technician to observe and compare the readings obtained from the ATF temperature sensor and the ECT sensor 2. If both readings align with the ambient temperature during the checks from Step 1, the technician can confidently move forward to Step 6. However, should the readings differ, it necessitates further investigation. The technician must ensure accurate recording of the ATF temperature as measured via the HDS in the AT data list. This comparison is integral in determining whether the sensor is functioning within expected parameters, as discrepancies may indicate a potential failure or electrical issue that requires further attention. Attention to detail during this step will pave the way for a more thorough understanding of the sensor's accuracy. In this step of troubleshooting, the technician must record the ATF temperature utilizing the HDS before proceeding further. This recorded value serves as a reference for future comparisons and assessments. Following this, it is essential to turn the ignition switch to the lock position, thereby completely shutting off the vehicle's electrical systems. The technician should let the vehicle remain in this state for a minimum of 30 minutes. This downtime period allows for any electronic systems to reset and ensures that subsequent measurements taken will reflect the true operating conditions of the ATF temperature sensor. This step is crucial as it establishes a controlled environment to further investigate the sensor's performance and reliability in delivering consistent temperature readings. During this step, the technician is required to compare the current ATF temperature reading to the value recorded in the previous step. It is essential to check whether there has been a notable change in temperature over the 30 minutes of system inactivity. This comparison is important in determining whether the sensor is functioning properly or exhibits intermittent failure. If a change in temperature is noted, the next action would involve leaving the engine off for at least 6 hours. This additional waiting period allows for a more accurate assessment and could reveal patterns relating to temperature changes. Conversely, if there is no difference in the readings, it is likely that the ATF temperature sensor itself may need to be replaced, as it could indicate a persistent fault in sensor functionality. In this crucial step, the technician must again utilize the HDS to record the values of the ATF temperature sensor alongside those of the ECT sensor 2. Both measurements directly correlate to the efficiency of the cooling mechanisms associated with the transmission and the engine. Once these values are documented, the next task is to compare them for significant differences. The technician should look for whether the ATF temperature reading exceeds the ECT reading by 58 degrees Fahrenheit, 32 degrees Celsius, or if it drops below the ECT reading by 43 degrees Fahrenheit, 24 degrees Celsius. If either of these conditions is met, it indicates a malfunctioning ATF temperature sensor that should be replaced promptly. Understanding these comparisons is essential for determining the overall health and functionality of the vehicle's temperature monitoring systems. Upon concluding the necessary repairs, specifically if the ATF temperature sensor has been replaced, it is crucial to perform final verification steps. The technician should recheck the ATF temperature and ECT sensor readings to ensure they are within normal operating ranges. This step confirms that the new sensor is functioning correctly and no further issues are present in the circuit. It is also advisable to monitor the vehicle's performance closely during a short test drive observing for smooth shifting patterns and ensuring that temperatures remain stable. This holistic approach not only validates the repair, but also ensures the longevity and reliability of the transmission system. Achieving stable readings post-repair confirms that the issue related to DTC P0714 has been resolved effectively. To prevent future occurrences of DTC P0714, it is essential to implement a regular preventive maintenance schedule. Regular transmission fluid checks should be performed to ensure that fluid levels and conditions are optimal. Degraded fluid can affect sensor performance. Equally important is the inspection of wiring connections related to the ATF Temperature Sensor. Periodic checks can catch wear and corrosion early on, mitigating potential electrical issues. Additionally, conducting routine diagnostic checks using the HDS can help identify anomalies before they become serious problems. Engaging in these preventative measures contributes to the ongoing reliability of the automatic transmission system, enhancing overall vehicle performance and safeguarding against unexpected faults. In summary, the DTC P0714 code signifies an intermittent issue with the ATF temperature sensor in the Honda Odyssey from 2011 to 2017. Understanding this error code is fundamental in ensuring the longevity and reliability of the vehicle's transmission system. Following a systematic troubleshooting process, from recording initial readings to validating sensor functionality after repairs, enables technicians to accurately address the problem. Implementing preventive maintenance, such as routine checks of fluid levels and wiring, will further reduce the likelihood of future failures. By being proactive and efficient in diagnosing and addressing the DTC P0714 error, vehicle owners can secure optimal performance and prevent costly repairs down the line. Please like and subscribe to the channel. See you next time.